Good evening, everyone. Thanks to M2D2 for this opportunity. I'm going to discuss our technology for harvesting radio frequency or RF energy and this application. So it doesn't advance. Oh, sorry. Okay. Here's my partner, Professor Law, and he was working on the campus of Carnegie Mellon University. As a physicist, he was feeling warm, basically from receiving the power, the thermal electromagnetic wave from the environment, also the RF wave from the air, namely the cellular signal, the TV signal, Wi-Fi, and Bluetooth signal, right? And the question on his mind is, how can we harvest those energy in a clean, effective way? So that leads to the research and the invention of the high-speed diode. Okay, so on the left is the so-called invention, the MSM diode. The challenge to harvest those waves because the frequency is so high. And our diode can work really well up to terahertz. And it's 100 to 1,000 times faster than any state-of-the-art commercial available diode. And among all the promising technology, we choose to focus on RF energy harvesting. Essentially, we can generate electricity from the free ambient radio signal to power the IoT device and the medical device. The key advantage of our technology is very high efficiency. It's at least 10 to 100 times faster to make it feasible to power those devices. And looking at the market opportunity, one of the key a key problem with the battery is a limited lifespan. So the replacement cost is very high. There's quite a few large potential market. We plan to focus on the active implantable medical device first. We believe our technology will allow the deployment of billions of IoT devices and allow the new functionality of implantable device. And just look at the battery market for the implantable device is already over $500 million. And the potential saving on the medical surgery cost can be up to $2 billion per year for those implantable devices. We have completed a prototype. We have demonstrated a working IoT sensor that can collect, process, and transmit data. And just to put in perspective, in the typical urban environment, like here or in the downtown Boston, where it can collect up to 25 to 500 microwatt power. And for some of the pacemaker, it consumes around 10 to 20 microwatt. And so we have considered preliminarily some of the key issues for the medical application. We think we can provide a reliable, effective solution. We have granted global patents already. We got an exclusive license from CMU. We complete the prototype. We have a grant or partnership with a major energy company enough to survive for the next 6 to 12 months. So we're here to looking for a partnership with a leading AIMD player and to do commercial product development and FDA process. We're looking for venture capital investment. Okay, so how to play the video. But essentially what you're looking here on the left is a prototype. It's supposed to blinking, the LED. So it's an ambient device. Right now it's a fraction of a quarter, but it can be shrunk to a millimeter by half millimeter size. We plan to integrate it with a device battery first to extend the life. Thank you.
Thanks very much for the very interesting presentation. Sorry we didn't get to see the video. Can you tell us a little bit about, so it seems like it's a very miniature technology, but can you tell us a little bit about the size of the RF antenna to enable that sort of power harvesting?
Yeah, the power level I told you is assumed the antenna is about the size of a palm. But because we have given the power budget, right now if we can collect 100, we only use a 10, we can shrink by 10 times the antenna size. That's the beginning point. For this particular implantable device, look at the little chip. I say I can make it about a millimeter by half a millimeter. And the antenna can be used the wire of the pacemaker, so it doesn't take any actual space. So that's the plan.
Very much.
Okay, thank you.